The fan cannot capture welding fume that never enters the hood.
This real automated joining cell establishes the source process. The plume overlay explains the airflow question.
If the plume crosses a worker's breathing zone first, a larger downstream blower cannot undo that missed capture. Start with the control hierarchy. Reduce or enclose the fume-producing process where practical.
Place local exhaust as close to the source as the work allows, and use appropriate respiratory protection whenever extraction alone is inadequate.
The exact process, metal, coating, and consumable determine the hazard review. But distance and orientation shape the capture envelope. A distant hood must control more surrounding air.
Aim it so the natural plume travels toward the inlet, keep the worker out of that path, and avoid obstructing the work.
One capture velocity number is not a universal design rule. Room air can defeat a good-looking hood.
Open doors, cooling fans, compressed air jets and vehicle movement may bend the plume away.
Test realistic worker positions and worst credible crossdrafts, not only an empty, still workstation. Choose a method that follows the source.
A movable hood works only when repositioned correctly. On-torch extraction stays close to the arc.
A downdraft bench pulls away from the breathing zone. A partial enclosure contains more of the plume. Each changes access, flow, and pressure loss. Now follow the captured air.
Hood entry, flexible duct, elbows, branches, the air cleaner and final discharge all add resistance. The blower must overcome the complete path.
Maximum free airflow is not installed extraction flow. Cleaner loading changes that path.
As media loads, differential pressure rises and capture flow may fall. Measure filter pressure, define a service limit and verify the hood after maintenance. Motor speed alone cannot prove that capture still works.
Select the blower where its curve intersects the dirty system curve at the required flow.
Check power, speed range, sound, temperature, leakage and service access at that point.
Keep realistic loaded state pressure margin without simply oversizing everything. The backward curved fan shown here is a clean airside architecture example.
Hot fume, corrosive gases, sparks or combustible particles can change materials, impeller construction, motor placement and certification.
Never infer hazardous process suitability from a product photograph.
Discharge, recirculation and makeup air are separate decisions. Exhaust contaminated air clear of intakes in occupied areas, or follow an approved treatment and recirculation strategy. Replace extracted air with clean air without creating a crossdraft that ruins capture. Before selecting hardware, stop for the hazard gate, base metal, coating, consumable, gas or vapor, combustible particles, ignition sources and electrical location.
Industrial hygiene, fire and explosion protection, respiratory protection and local rules may control the design.
Commission the real workstation. Use appropriate capture visualization, airflow and pressure measurements, filter differential pressure, fan status and alarm response. Check worker position, hood usability, discharge and clean makeup air.
Repeat after process changes and on a planned maintenance schedule.
For an engineering review, send the process, materials, hood geometry and position, duct loss schedule, cleaner data, dirty system point, blower arrangement, discharge boundary, makeup air and acceptance tests. That complete package turns a fan into a working local exhaust system.